So let's go over the product and quotient rules. So when we have this function, it's a constant times a function, and we can just copy the 3 and take the derivative of sine. But if this is not a constant and it's a product, we want to make sure that we don't just do the derivative of x and the derivative of sine. We have to use the product rule. And if you just set it up like this to start, it'll prevent you from forgetting what to do at the end. So we have these 4 spaces, and we copy the first factor, and then we use the derivative of the second factor. So that's cosine. Here we copy the second factor, sine, and do the derivative of the first factor. That's the product rule, and we have a similar rule for quotients. So if we have a quotient, we will copy the denominator here times the derivative of the numerator minus the numerator times the derivative of the denominator, and that's all over the denominator squared. And we can just rewrite that. And we're just going to look at some functions with some more complicated algebra that we didn't see the first time we did this. All right, let's find the derivative. So if we're going to do a derivative of this, let's write it as a exponent. It's a product, so the derivative uses the product rule. So we'll copy the first factor, do the derivative of this. So the derivative of 4 is 0, and here we get negative 2x. And then we'll copy the second factor and then find the derivative of the first factor, 1/2 x to the negative 1/2, using the power rule. And let's rewrite this. Negative 2, let's write this as x to the 3/2, because there's a half and there's a 1, so we have 3/2. Let's write this as, let's write it as a radical x. All right, so we have a negative exponent. That means it goes in the denominator. The 2 is already in the denominator. In calculus books, they often they just factor from this point instead of writing it as a rational. But if you write it as a rational, you can just focus on getting a common denominator, and I think that's a little less confusing. So let's get a common denominator, and that would be, we need this over here, so let's multiply by 2 radical x in the numerator and denominator. So now we're going to have negative 4, and this is square root of x cubed. Here we have square root of x, so that'll be square root of x to the 4th. And 2 radical x in the denominator. 4 minus x squared, 2 radical x. And here we're going to simplify. Let's combine all of this. So we have negative 4. This can be rewritten as x squared plus 4 minus x squared and we'll just combine that to get negative 5x squared plus 4 over 2 radical x. Okay, pause the video and try that one. So now we have the first times the derivative of the second plus the second times the derivative of the first two in the denominator, negative exponent, we'll put that radical in the denominator. Let's get a common denominator, so we'll multiply by 2 radical x. And now we have 2x cosine x plus sine x over 2 radical x. And we don't see this very often, but when you multiply these two numbers, this is always positive, this is always positive, so when we multiply, the answer is always positive. But if I just write an x, that's saying that x can be positive or negative. So in this case, we have to do that. So that's back from Algebra 2. Now we have a quotient, and let's write it as a fractional exponent. And now the derivative follows that template, and we're going to use the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. The derivative of 1 is 0, and then we'll do the derivative of x to the 1/2. So that's 1/2 x to the negative 1/2, and the denominator squared. So let's write that as a, this will just be radical x minus 1. Here we have x to the 1, which is 2 over 2, times x to the negative 1 over 2. So we have 2 over 2 minus 1 over 2 is 1 over 2. So we have a 1/2 x to the 1 over 2 is radical x. And then we can combine these, so that's 1 minus 1/2 is 1/2. And sometimes that would be written as, or we put that 2 in the denominator. Pause the video and try that one. Find the derivative. Don't have to worry about any radicals. So we have the denominator times the derivative of the numerator. Numerator times the derivative of the denominator. And the denominator squared. Here we have a common factor of t squared, and we could take the t squared out. So then we reduce. Okay, let's review tangent lines. So to find the equation of a tangent line, we have to find the slope and then use point slope. The slope is the derivative. We have a product. So that's going to be the first factor times the derivative of the second factor, 2x. And then we'll have the second factor times the derivative of the first factor. We don't have to worry about simplifying because we're just going to evaluate it at 0. F prime of 0, 0 minus 1, 2 times 0, 0 squared minus 2, so we just get negative 2. Because this is 0 times negative 1, that's 0, and here we just have negative 2. So then with the point slope, y minus y, m, x minus x. Find the equation of the tangent line to this function at that point. Pause the video and try that. So we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. And let's just evaluate it at 2. 2 plus 1 times 1. 2 minus 1 times 1. 2 plus 1 squared. 3 minus 1 over 9 we have y minus y equals m x minus x we're going to add 3 over 9. So 1 over 3 is 3 over 9. All right, so we just have to find out when the slope is 0 and then find the y value. So let's find the derivative. Denominator times the derivative of the numerator. Numerator times the derivative of the denominator over the denominator squared, 2x cubed plus 2x. So we're going to distribute 2x times x squared, 2x times 1, and then here we have 2x cubed we want to know when that equals 0. So if we want a horizontal asymptote, the slope has to be 0. So let's set that equal to 0. So a fraction equals 0 when the numerator equals 0. Also, we wouldn't want the denominator to be 0, so if I put a 0 there, the denominator is 1. So that tells us that if x equals 0, we'll have 0 over 1, which equals 0. And then we just have to find the point, and that's going to be the point when the tangent line is 0, or horizontal would be that. And so we just substitute a 0 into the function. We get 0 over 1, so the point is 0, 0.